Okay, so let us start today's discussion. Okay, let us start today's discussion. So last day we were solving some examples of expectation. So we will continue that and we'll solve some more examples. Okay. So let's start with a very simple example. Example 1. Okay. Hope I'm audible. And before starting, if there is any doubt regarding any previous sessions, please ask or write in the chat box. Okay, even in between also you can write or ask. So example 1. When a die is rolled or thrown, if we are throwing a die, okay, then what is the expected probability? What is the expected probability of getting a particular number? This is the question, right? So let us solve this question. Okay, if we throw a die, if we throw a die, then we may get the value between 1 to 6, right? Okay, if die is fair, so we are considering that what die we have considered is fair. Okay, so basically the probability of getting any number let us P of x is equal to I, okay, is one upon six for I is equal to 1 to 6, right? Fine. Okay. Now for any I, the probability is 1 by 6. So the probability of getting a particular number is 1 by 6. Then what will be the expectation of x? This is nothing but summation of xi into pi. If we denote it as pi, so if we write it as pi, then it will be I is equal to 1 to 6 xi into pi. Okay, so better we can write it as xi also. For I is equal to 1, x1 is 1. Similarly for I is equal to 6, x6 is 6, right? So we can write it like this also. 1 upon 6 is constant for any I. Pi value is constant for any I which is 1 upon 6. Then it will be 1 plus 2 plus 3 plus 4 plus 5 plus 6. Fine. So what will be the value? It will be 3.5, right? Okay. Let us create some space. Okay. Okay. So this is fine. There is no query. Okay. Then come to example 2. Okay. Okay. Let x be a uniform distribution. with PDF f of x is equal to 1 upon 10. Okay, for -5 less than is equal to x less than is equal to 5. Fine. Now this is our given thing. Question number 1 is not question number 1, part 1 of example 2, right? Find expectation of x. So this is the first part of our question. Okay, so let us solve it first. X is continuous, so we can write expectation of x is minus infinity to plus infinity x f of x dx. Till now it is clear. This is nothing but the formula of expectation, right? Okay, so we can write it as -5 to +5 x upon 10 dx. Okay, why? Because this is uniform distribution between -5 to +5. It means, as it is mentioned that it is uniform distribution, in the other value of x, if x is 0, right? Okay, so now we can write it as 1 upon 10. This is what? -5 to +5. This is +5, right? Or rather, write it like this. Okay, x dx. Okay, and this we can write 1 upon 10 x square by 2 from -5 to +5 is equal to, we can write 2 will come out 1 upon 20 plus 5 square means 25 minus 5 square means 25 is equal to 0. Okay, it is clear. Now come to the next part of this question, and this is part 2. Part 2 is find expectation of x square. Okay, so expectation of x square will be minus infinity to plus infinity x square f of x dx, right? Okay, students, please try to solve it. You please take 2 or 3 minutes and try to solve the question, and then match the answer with our answer. Okay, first take 1 2 minute and try to solve. Have you solved? If yes, then please match the answer. This will be minus 5 to plus 5. X square by 10 dx. Okay, so again we will keep 1 upon 10 outside. It will be x cube by 3 minus 5 to plus 5. Okay, we can write it like this: 1 upon 30 and then 5 cube means 125 minus of minus 125, that is plus 125. So we will get 250 upon 30, which is 25 upon 3. Okay, we are getting nothing but this only, right? Now come to part 3 of the question. Find expectation of two x plus 5. Okay, so can we write expectation of 2x plus 5 like this? 2 into expectation of x plus expectation of 5. Yes. And what is the value of expectation of x? It is 0, right? We have calculated here. So this part will be 0. 2 into 0 plus expectation of any constant is the constant itself. So this is 5 is equal to 5. Okay. Now come to the fourth part of this question. Part 4 is find expectation of x plus 1 whole square. Okay. Okay. So expectation of x plus 1 whole square is equal to, we can write it, expectation of x square plus 2x plus 1. Okay, so we can write it like this. This is nothing but the expectation of x square plus 2 into expectation of x plus expectation of 1. Okay, Till now it is fine. Can we write like this? Any query or any question? No. Okay. So what is the value expectation of x square? We have already calculated. It is 25 upon 3. 25 upon 3. Okay. Plus 2 into expectation of x is 0. We have calculated it, right? Here. Plus expectation of 1 means 1. So this will be 28 upon 3. It is clear till now? Okay. Then we will go, for example, 3. Okay. We need some space, so let us create it. Okay, sorry. Okay. It was example 2, so we will go for example 3. Okay. Let x is a random variable. Okay. And the probabilities are shown in a tabular form. This is x, and probability of x is 0, 1, 2, 3. Okay. What is probability of x for 0? It is 1 upon 3. Okay. This is 1 upon 6. This is 1 upon 4. And this is 1 upon 4. Okay. So first check that whether, okay, our question is find expectation of x. Okay. Now first check whether the sum of these probabilities is 1 or not. 1 upon 3 plus 1 upon 6 is 3 upon 6, which is 0.5, right? And 1 upon 4 plus 1 upon 4 is 0.5. So total 0.5, and 0.5 is 1. So first thing is clear that the total probability is 1, which should be. Now let us find expectation of x. Expectation of x is I is equal to 1 to 4 xi p of xi. Okay, what is x1? X1 is 0, so it will be 0 into p of x1 is 1 upon 3. Plus x2 is 1, so 1 into 1 upon 6 plus 2 into 1 upon 4 plus 3 into 1 upon 4, right? Okay, so this is 1 upon 6, this is 0, so 1 upon 6 plus 1 upon 2 plus 3 upon 4. And what will be the final result? This is 1.42. Fine. Is it clear till now? Please take 1 and 2 minutes and see whatever we have solved till now. Then we'll go further. Okay. What we have solved till now, please check. Take 2 minutes. Okay. Let us come to example 4. Find mean of a binomial distribution function. Okay, find the minimum of a binomial distribution function. For a binomial distribution function, what is the density function? So we know that for binomial distribution, density is, please look the solution carefully, okay, because it is very important. And interesting too. Let us define k is equal to 0 to n. Okay, nck p to the power k 1 minus p to the power k, not k, n minus k into delta x minus k. Okay, okay. Now x is the random variable, and for any k, we can write it that probability p of x is equal to ncx e to the power x and q to the power n minus x. What is q? Q is nothing but 1 minus p. For x is equal to 0, 1 up to n. And q is equal to 1 minus p. Now, what is the expectation of x? x is equal to 0 to n x into px, and this is x is equal to 0 to n x in cx px p to the power x, rather q to the power n minus 6. Okay, till now it is clear. Is there any query till now? Please look into this and try to understand. Now this we will use further. Okay, this I have marked because we need this in further, but now let us calculate this, how it looks like. ncx is equal to n minus 1 up to, or rather we can write it like this, n minus 2 and dot 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 up to whatever. Okay, 3 to 1. Okay, and we can write it in denominator x minus 1 x minus 2 and so on. Is it clear till now? Okay, now can we write it like n upon x into this whole part multiply with n minus 1 n minus 2 and so on. Similarly in denominator x minus 1 x minus 2 and so on. So this is nothing but n upon x n minus 1 c x minus 1. Okay, okay. So now we will consider this again. Come to this part. Okay, is this part clear to everyone? Okay, now please come to here. Expectation of x was this, right? So we will replace this using this. Okay, so we can write x is equal to 0 to n x n upon x n minus 1 c x minus 1. P up p to the power x q to the power n minus x. Okay, okay. So we can write it, x will be cancelled out. So this is x is equal to 0 to n n n minus 1 c x minus 1 p to the power x q to the power n minus x. Okay, now can we write this is equal to x is equal to 1 to n? Yes, we can write. Rather, we can do one step here only. It will be more easy to understand here. If we write it like this, x is equal to 1 to n. So is it okay? Not here. Here itself we can write. It will be more easy to understand for you. If we write it x is equal to 1 to n and whatever it was. Let's just copy paste. C and control C. Okay. So switch it where it was earlier. Okay. Now please have a look that why I am writing this from x is equal to 0 to n to x is equal to 1 to n, because if we put x is equal to 0, then this value will be 0, right? So there is no valid value, or there is valid value but it is 0, right, at 0. So we can easily write it from x is equal to 1 to n. So here also we will write, till now it is clear. Step by step we are taking. We could explain it earlier also, but it was not required at that time. But why I am doing this, you can understand here. So let us rewrite it with a rearrangement. X is equal to 1 to n. Let us write it as n p x minus 1. Okay. Now as we have written p already, so it will be p x minus 1 instead of p to the power x, right? And can we write this q as n minus 1 minus x minus 1? It is same as q to the power n minus x, right? Okay. This whatever we have got till now. Now let's take np outside. This is x is equal to 1 to n n minus 1 c x minus 1 p to the power x minus 1 and q to the power n minus 1 minus x minus 1. Okay. Now come to a very interesting point. Can we write this as p plus q to the power n minus 1? This whole. Yes, we can write like using binomial distribution only. N minus 1. Now we know that q is equal to 1 minus p, so p plus q is equal to 1. So it will be np multiplied with 1 to the power n minus 1, and the value is nothing but np. Okay. So we are getting expectation of x is equal to np. Okay, this is the entire derivation. So please, you people take 2-3 minutes and try to understand what we have done till now. Okay. So have you looked in the derivation? Is there any confusion till now? Whatever we have done. If no, then we'll go for example 4, 5. Sorry. Okay. Find mean of a Poisson's distribution function. Okay. Okay, let us find the mean of the Poisson's distribution function. So what is the PDF of a Poisson's distribution function? Hope you know and you should know. This is the PDF. K is equal to 0 to n e to the power minus lambda lambda to the power k divided by k factorial multiplied with delta x minus k. Okay, so the probability mass function for x, we will get p of x e to the power minus lambda lambda to the power x factorial for x is equal to 1 and so on. Okay. Okay. Now we will find expectation of x. So it is also very interesting derivation. Please look it carefully and try to understand. This is x is equal to 0 to infinity, we can write, because it is up to infinity, right? Poisson distribution is an infinite series. X e to the power minus lambda lambda to the power x factorial. Again, can we write it from 0 to 1 to 1 to, sorry, from 0 to infinity to 1 to infinity? Yes, because for x is equal to 0, it is nothing but 0. So let us write. Okay. And we can write it like e to the power minus lambda, we can put outside, 1 to infinity it will be x lambda to the power x, and x factorial we can write it as x into x minus 1 factorial. Okay, please try to understand whatever I have written till now. And is it clear or not? Please tell. This is px, the probability value at point x, and expectation of x we can write like this. Okay, so sorry. Let us continue. Can we write it e to the power minus lambda x is equal to 1 to infinity lambda to the power x minus 1 factorial. Okay, now we will rearrange it. We will write like this. This is very crucial and important step. Please look it carefully and try to understand. This will be x is equal to 1 to infinity this is lambda multiplied with lambda x minus 1. We can write it like, okay, e to the power x, e to the power lambda we can write like this, e to the power minus lambda as it was, and it is x minus 1 factorial. Okay. Now just take the lambda outside and rewrite it. It is clear. Now we need this part. What this part indicate? Let us write here. Okay, this is nothing but the sum of all probabilities. Is there any difference between this and this? No. Okay, so if this is the sum of all probabilities, then what should be its value? Factorial, and its value is 1 because sum of all probabilities is 1. Okay, so this value is nothing but lambda. Okay, so we are getting expectation of x is equal to lambda. fine. Please take 1 2 minutes and try to recall what we have done till now. This part especially. Try to understand if there is any query, please ask. Sorry, please look over this. This is the entire derivation. Is it clear? So this way we can calculate the mean of binomial distribution. And what will be the variance of binomial distribution? It is NPQ. We can calculate it in similar way. You all know how to calculate variance. So please try to calculate and check whether the result is coming in PQ or not. Okay. We will move in another interesting question. Example 6. Example 6. 5 coins are thrown simultaneously. Okay, 5 coins are thrown simultaneously. Find mean and variance of getting ahead. Mean and variance okay. So can we write it as a binomial distribution? Yes. So what will be the value of n? N is equal to 5. Okay. What is p? P is the probability of getting hit, and it is half only. P is of hit, and this is half. What is q? Q is 1 minus p, and this is also half. Okay. Okay. And what is n? N is the number of coils. Okay. So mean of x expectation of x is equal to np. We have already calculated. N is 5 multiplied with half, so it is 5 upon 2. Okay. So this is mean. So mean is Mean is this. Now we will calculate variance. Variance is in PQ. Please try to derive it. If you cannot, then please ask me in next class. I will derive. Okay? But I hope you can do it easily. This is 5 multiplied with half multiplied with again half, right? 5/4. So we are getting the variance is 5/4. Okay. Please take 1-2 minutes and try to understand whatever we have done, whether it is clear to you or not. If there is any queries, please ask. Okay, let us come to example 7. It is a very interesting question. Mean and variance of a binomial distribution is given. What is given? For a binomial distribution, mean is equal to 6. and variance is equal to 2.4. Okay, this is given. Find probability of x greater than 2. Okay, this is our question. Can you try to solve this? It is very interesting question. Please take 1 and 2 minutes and try to solve this. At least try to think how can we solve this. So have you got any idea how to get the solution? Okay, if you have done something, please match with the answer, and if you have not done, then look at the solution. Okay, mean is given. Mean means NP. NP is 6. Okay, variance is given. Variance is NPQ, and this is 2.4. Okay, so from this, can we calculate N, P, and Q? No. Or yes? Look, there is 3 variable and 2 equation only. So it is looking that we cannot. But there is another equation we already have, as it is binomial distribution. So P is equal to 1 minus Q, right? Or Q is equal to 1 minus P. So 3 equation and 3 variable we can calculate. Okay. If we divide this by this, then we will get now if we write NPQ divided by NP, then we will get Q, and what is this? NPQ is 2.4 divided by 6, and what is the value? 0.4, right? Okay, 0.4. Okay, if Q is 0.4, so P is, what is the value of P? P is nothing but 1 minus Q. and this is 1 minus 0.4 is equal to 0.6. You understand till now? Now, what is remaining to calculate? It is n. Fine. Okay. How can we calculate n? This is np is equal to 6. So, can we write n is equal to np by divided by p, and np is 6, p is 0.6, so this is 10. Is it clear till now? Now we have n, p and q, all three results. Okay. Okay. What n is equal to 10 indicates? It indicates that number of experiment is 10. Okay. Now the question is, now we need to find probability of x greater than 2. This is our question. Fine. So can we write px greater than 2 is equal to 1 minus px less than or is equal to 2? Can we write it? Yes. How? Because total probability is 1. Okay. Is this line clear to everyone? If here you are getting any confusion, you may ask. But why we are writing this in this form? To make the calculation easy. As it is a binomial distribution, we can write 1 minus this part. You can write p of x is equal to 0 plus p of x is equal to 1 plus p of x is equal to 2. Okay. Okay. Now you can relate that why I am writing it in this form. If not in this form, we can write it is this is equal to p of x is equal to 3 plus p of x is equal to 4 and so on up to plus p of x is equal to 10. So how many terms will be there? 8 terms. Instead, here we are calculating only 3 terms. So it is easy, right? Okay. So let us write, or let us calculate it separately for your easy understanding. This is npx, right? X is 0, so and n is 10, so we will get n c0 p to the power 0. Q is 10 minus 0, that means 10 only. Okay. Now we have the value. This is ten C0 P means 0.4, no, 0.6, so 0.6 to the power 0 multiplied with 0.4 to the power 10. Is it clear? And what is the value? You can calculate this. Yeah, it is nothing but the 1. This is 1 and this is 0.4 to the power 10. So this is okay. Now we will calculate P of x is equal to 1 in similar manner. This is 10 C1 P to the power 1 and Q to the power 10 minus 1 is 9. Fine. Okay. So this is, what is 10 C1? It is 10 factorial divided by 1 factorial into 10 minus 1 means 9 factorial into P means 0.6 to the power 1 into q, 0.4 to the power 9. Sorry. Okay. Okay. So this is nothing but 10 multiplied with 0.6 multiplied with 0.4 to the power 9. Can you calculate p of x is equal to 2 in similar manner? Please calculate. Take 2 minutes and try to calculate. And then match the result. Please try to calculate. Okay. Have you calculated? Okay. So let us see. This will be, if you have calculated, please match with my answer. P to the power 2, q to the power 8. 10 minus 2, right? Okay. So this is 10 factorial upon 2 factorial upon 10 minus 2 is 8 factorial. Okay. Into p square means 0.6 square, and 0.4 to the power 8. This is equal to 10 cross 9 upon 2 into 0.6 square multiplied with 0.4 to the power 8. Okay. Now come to the solution of this line. Okay, this line of the solution. This 3 we have calculated, so let us write the value. Zero 0.4 to the power 10. It is 1.048 multiplied with 10 to the power minus 4. Okay. Okay. What is the value of this? Let us calculate. 0.4 to the power 9 multiplied with 0.4 multiplied with 10, and this is 1.57 multiplied with 10 to the power minus 3. Okay, and now calculate this. 0.6 to the power 2 multiplied with 0.4 to the power 8 multiplied with 10 into 9 by 2, right? And this is 0.0106. Okay, now please try to understand what p x is equal to 0 indicates, what p is equal to 1 indicates, and sorry, p of x is equal to 1 indicates, and what p of x is equal to 2 indicates. What was the question? It was a binomial distribution. So can we resemble it like there is, if n is equal to 10 we are getting, so there is 10 experiments, so let us toss a coin 10 times and let us get that coin is biased. Okay, somehow it is biased, and the possibility of getting a head or probability of getting a head is 0.4 and probability of getting a tail is 0.6. So if this is the situation, then p of x is equal to 0 indicates that probability of no head P of x is equal to 1 indicates probability of one hit in the entire 10 experiment, and P of x is equal to 2 indicates the probability of getting 2 hit in the entire 10 experiments. Okay, so now let us calculate this. So we can write probability of x greater than 2 is equal to what physically it interprets. If this is the question, although this is not the question, we are just saying it, there is a binomial distribution. It can be any experiment, but if the experiment is coin toss, and this is the scenario what I have explained, then probability P of x greater than 2 indicates that probability of getting more than 2 hits, right? Okay, so it is 1 minus the sum of all these 3, right? This plus okay. So what will be the answer? It is 1 minus, let us calculate, plus 57 multiplied with 10 into 10 to the power minus 3, and it is 0 0.0123. Okay, and this we will get 0.9877. Okay, so this is the answer. We can also calculate it in another way, that probability of x is equal to 3 plus probability of x is equal to 4, and up to probability of x is equal to 10. In the same manner we can calculate and we will get the same result. You can try it by your own. Okay, okay, thank you.